Hello everyone. So this is a question I was going through of FIT JEE AIATS of past year. One of my students sent this one, or I think this problem is in the krotov also. Okay, so the question given is four identical massless rods are connected hinge to form a rhombus of side length 5√3. Rods can rotate freely about the joints. The joints B and D are connected by massless spring of relaxed length 7.5√3. The system is suspended vertically with a load of mass M. Attach the equilibrium of the rod is given as at 30 degree with the vertical. You need to find out the time period. You may see that whenever you will pull up this one, whenever you will just pull the string, what will happen? I am just illustrating you. So this is the condition basically. Whenever what you will do, whenever you will just pull this one, so as the length of the rod are changing, so mass will move up or downward, and this will cause a harmonic motion, SHM. Okay, so as I was doing, I was starting to solve the problem. What I have approached is the energy. First I was doing by force method, right? So the force method is if for equilibrium, as the question is given, so you can do what, like 2d cos, this is t, so this one is theta, so this one is theta, so this is theta also, so this is 2t cos theta, and on the other hand, what we are getting, 2t cos theta is cos 30 is given at equilibrium, so t is equal to mg by root 3, and then 2t sin theta is equal to kx, and in place of t you just put mg by root 3, k is equal to mg by root 3x. And what I assume, if this is length L, I am just doing it by violet color. So this is length L, so this can be L cos 30. So this total is 12 cos 30, 12 sin 30. 12 sin 30 is how much? That is this one. This length is 12 sin 30. Okay, this we will be using, and you know that this is L is 5√3. This is 7.5√3. So if this is L, you may write this one, this total length as 1.5 L, the length of the original length of the spring. Okay, so K by M you are getting from here. Whenever the mass will come downward, what will happen? The B and D will approach each other, and B and D, as they will approach each other, the length of the spring will be shortened, and a compression will be happening. So S is equal to 2 into 5√3 sin 30 minus 7.5√3. This is coming because this is L, so this total length you may write, or you may write, if this 5√3 is L, so you may write 2L sin 30, that is L minus 7.5√3, or you may directly write the earlier one, that is 2 into 5√3 sin 30, so 2 and 2 cancel, sin 30 is 1 by 2, cancel out, 5√3 minus 7.5√3, that is minus 2.5√3. So x is coming like 2.5√3. Okay, so I am just keeping it as it is. I'll put it later on, or you may write this one like 5√3 is L, so you may write this one as L by 2. You may write this as L by 2. So I am just doing this one, k is equal to mg by root 3x. In place of x I have put L by 2, so this k is coming to mg by root 3. I am doing so because to minimize the number of constant values. I will put it on later on, I will put it on the equation later on. Okay, so k by m is equal to 2g by root 3l. Now moving on to the energy form, because if you do if you approach, like, let's assume you can do these things like this way also. Let's there is a displacement of y, as in the krotov solution it has been given, but now onward I thought to approach with the energy equation. So the energy equation is like these are the basic calculation I have done. You know that from calculus, fx plus delta x is equal to fx plus del f by del x into delta x, and in SHM you might have read that f is equal to minus kx, so minus del u by del x is equal to minus kx, so k is equal to del 2u by del x2. So from there, at equilibrium the net force is 0, fx naught is 0, so fx naught plus delta x is equal to del f by del x x naught into x into is equal to ma, because if whenever you let's say there is a displacement of x from the equilibrium position, so there will be an acceleration or a net force, that is m into a, and a is coming like how much, del a by del x into x, del a by del x at x naught into x. Okay, now what we can do, del a by del x is what, del a by del x is del 2u by del x2 minus is equal to m by x del 2x by del t2. So the equation is coming, I am just taking this x over here. Okay, so equation is coming, del 2x by del t2 is equal to del 2u by del x2 by m into x. So that is coming like omega square is equal to del 2u del x2 by m. So as this is omega square, you may find out omega. So what I have to do here, I need to find out the energy equation, then I need to just differentiate it. So let's say there is a displacement of y, so the mass over here will be having energy. If this is a reference line, this is origin, so minus mgy plus half k x square. In place of x, what I can do, I can write this one, the initial length was 1.5 L and the compression is the original length was 1.5 L and the compression is y tan theta, because this one is y by 2, so this one will be y by 2 tan theta, and to multiply this with 2 because there are two sides, so y by 2 tan theta into 2, so that is y tan theta. Y get cancelled out, you just put the value of tan theta, that is 4L square minus y square by y, and y get cancelled out. So the value becoming u is equal to minus mgy plus k by 2 1.5 L minus 4L square y minus y square square. Just you need to differentiate it. This is simple calculations. 2 will get cancel out, just square it and then find out del u by del y. Del u by del y you are getting minus mg k by 2. Just differentiate this one. This is a constant term 9 by 4L square, and this 4L square also constant, minus y square is minus 2y, and this whole differentiation is becoming this one. Okay, I think you will know the differentiation very well. Okay, you know the differentiation very well, I think so. Now what you need to do, I am just doing dtu by dy2. Otherwise to go through the energy equation only, you may equate it to 0 to find out the value of y, because du by dy is 0, that means force is 0, so you will get the equilibrium position. As earlier I got the equilibrium position from the force equation, so I am not doing so, I am just differentiating it with respect to y. So d2y by dy2 is equal to minus m by mg k by 2 minus 2. Again I am differentiating it, and just after you may take the screenshot and solve this one on your own. So what I got minus mg, sorry, there will not be minus mg because I am differentiating a constant term, that is minus mg. So I am getting k by 2 minus 2 12 L cube 4L square minus y square to the power 3 by 2. And as you know, the equilibrium condition, what I am getting, the angle is 30 degree. So if this is L, this is 30, so this one is L cos 30 and this one is also L cos 30, so total value is 2L cos 30 at equilibrium. So y is equal to 2L cos 30, so in place of y just put 2L cos 30, you are getting 5k, this one del 2u by del y2. So you know the formula, omega is equal to del 2u by del y2 by m. So del 2u by del y2, that is double differentiation of u, is coming 5k by m, and in place of k, what you can do, you just put the value you got earlier, that is 2g by root 3l. You just put this one, 2g by root 3l. So you are getting what, you are getting 5 to the 10, just a minute, 2g by root 3l, root over 10g by root 3l. So the time period will be becoming 2 pi root over root 3l by 10g. This will be your final answer. Thank you, have a nice day.